Hello everyone, my name is Dr. Yogeshbhalla. So today we are going to start with the topic of ordinary differential equations. Now before discussing the topic of differential equations, first of all we will discuss what are differential coefficients. Differential coefficients. So the term dy by dx, or we can say d2y by dx square, or partial derivative curly y by curly x or curly 2y by curly x square, these are known as differential coefficients. Okay, so starting with the definition of differential equation, an equation which consists of differential coefficients is known as differential equation. For example, number 1, dy by dx plus 2y is equal to x. Number 2, d2y by dx square plus 3 times dy by dx minus 2y is equal to x square, or we can say curly 2u upon curly x square plus curly 2u by curly y square is equal to 0. These are the examples of differential equations. Now after coming to the topic of differential equations, the first thing we face, that is what is order and degree. So basically order deals with number of times derivative involved, we can say maximum number of times, and degree means index or power of highest order derivative involved in the equation. Okay, so we will take an example. Let us suppose we have first d2y by dx square minus 3 dy by dx plus 2y is equal to cos x, trigonometric part. Now this differential coefficient is of second order. This differential coefficient is of first order. So highest order, that means the highest order this involved in this differential equation is 2. So its order will be 2. Now if I talk about degree, the power or index of highest order. Now for this one, if I check, the power or index is 1. So its degree will be 1. One more example I will take. Let it be d2y by dx square minus of 7 dy by dx whole square minus 8y is equal to x. Now this one is of second order, this one is of first order. Okay, and we have to check about the order. So order basically deals with the highest order derivative, so it will be 2. And if I talk about degree, degree is the power of highest order. Now this is the second power, but it is for the first order, so I have not to deal with the first order, I have to deal with the second order, and its power is 1, so its degree will be 1. One more, curly 2u by curly x square plus curly 2u by curly y square plus 2 times curly 2u by curly x curly y, now is equal to 0. So this is a differential equation of second order, it is also second order, it is also second order, and throughout the second order the power is 1, so its degree is 1, and order will be what? Order will be 2, second order derivative. Okay, if I take one more example, so d cube y over dx cube plus 2 times d2y over dx square into dy by dx plus x square dy by dx whole cube equal to 0. Now I'll check. This one is of third order. This one is for second order. This one is for first order. Again this one is for first order. So highest order derivative involved in this equation is third order. So that means its order will be 3. Now come to the degree. So highest order will have whatever the index is over there. So that will be the degree of the equation. So it was degree will be 1. We will not go with 3 because it's a first order. Okay. So this will not work for us. Our working is with the highest order derivative. Okay. Index of highest order. I think so the concept is clear. Now when I deal with the differential equations, so basically two types of differential equations are there. The number one is ordinary differential equation and the second one is partial differential equation. So what are ordinary? Those equations which involve dy by dx or d2y by dx square. That means in which one dependent variable so we can define that equations which involve one dependent variable depends upon only one independent variable. For example, dependent variable I am taking about x and y, and for independent variable I am taking x. So that means those equations which involves dy by dx, or we can say second order d2y by dx square and so on, they are said to be ordinary differential equations. Now coming to the partial differential equation which involves curly u by curly x or curly y by curly x, curly y by curly y, curly y by curly z, like this one. Let us take a function f of xy. That means this function f depends upon two variables x and y. So when I take the differential equation for this one, so it will be curly f by curly x plus curly 2f by curly y square minus 2 times curly f by curly x curly y equal to 0. Now this equation involves partial derivatives. Okay, so that means this equation is known as partial differential equation. Okay, here one dependent variable and more than one independent variables are involved. Here f is the dependent variable and x and y are the independent variables. Okay, so this is a basic example of partial differential equation. Now coming to the solution of a differential equation. So basically first order differential equations of the following forms are solvable. Solvable means they have a solution. Okay, number one, that is variable separable form. Number two, form of the type dy by dx is equal to f of ax plus by plus c. Number 3, homogeneous. Number 4, linear differential equations. And number 5, exact differential equations. So one by one we will be discussing all the types: variable separable, dy by dx equal to f of ax plus by plus c, and then homogeneous, linear, and exact. So this video, or I can say this series, will consist of multiple parts explaining each of the types with number of examples. Okay. So today I am starting with variable separable form. So basically, what is the variable separable form? Let us take a question for that one. So question is, solve 3 times e raised to power x tan y dx plus 1 plus e raised to power of x secant square y dy is equal to 0, and they have given that y is equal to pi by 4 when x is equal to 0. So this is a statement for us today. So first of all, the given differential equation is 3 times e raised to power x tan y dx plus 1 plus e raised to power x into secant square y dy is equal to 0. First of all, what we have to check, whether any of the term is consisting of both of the variable at a single time. That means there should be no terms that involves e raised to power x into y. Okay, there should be no terms that no term that contains xy. So here e raised to power x is separate, tan y is separate. Here this part is separate, dependent on single variable x. This term is dependent on single term of y. Okay. So what I need to do, I need to separate both of the terms. So I'll take e raised to power x tan y dx is equal to minus of 1 plus e raised to power x secant square y dy. I take this term on the other side. Now here I am having x, so I'll keep all x terms over here. Now I'll take this one over here. E raised to power x is equal to minus secant square y over tan y dy, and here it will be dx. Now just check it. The derivative of this part is e raised to power x, and derivative of sin y is secant square y. That means we can apply the formula f dash x over f of x dx, that is basically log of f of x. So I'm integrating both of sides of this equation, so I'll getting 3 times integral e raised to power x 1 plus e raised to power x dx is equal to minus integral secant square y over tan of y and dy. Okay, so that counts to be 3 times log of 1 plus e raised to power x is equal to minus log of tan of y plus log of constant c. Now this 3 I'll take with the property of log, so this will be carried on the power. So log of 1 plus e raised to power x whole cube is equal to, now the property log m minus log n, so it will be log m over n c over tan y. Now taking anti-log on both sides, so it will be cancelled out, so result will be 1 plus e raised to x cube is equal to c over tan y. Cross multiplying both sides, so what I get, it will be 1 plus e raised to power x whole cube tan of y is equal to c. Let it be equation number star. So this is our solution basically for this one. But they have given a boundary condition. That means when x is equal to 0, y will be pi by 4. This boundary condition is always being provided to calculate the value of constant. So when x is equal to 0, y will be equal to pi by 4. So that means 1 plus e raised to power 0 whole cube into tan of pi by 4 is equal to c. So something power 0 is 1. So 1 plus 1, 2. 2 cube into tan pi by 4, that means tan 45, that will be 1 is equal to c. So that means c is equal to 2 cube, that will be 8. So equation number star reduces to 1 plus e raised to power x whole cube tan of phi is equal to 8. That is our final solution. Hope everyone understand the concept. Now one more question for more deeper understanding. So question is, solve x times cos of x cos of y plus sin y dy by dx is equal to 0. Okay, so this is a statement with us. अब मैंने इस क्वेश्चन को जब सॉल्व करें तो पहले चेक करना है कोई भी ऐसी टर्म नहीं है जो x और y दोनों पे कलेक्टिवली डिपेंड तो नहीं कर रही, क्योंकि ये सिंगल x पे डिपेंड कर रही है, ये सिंगल y पे डिपेंड कर रही है, ये भी सिंगल y पे डिपेंड कर रही है. तो फर्स्ट स्टेप क्या होगा, पहले मुझे एलसीएम लेना. सो इट विल बी x cos x cos y dx प्लस sin y dy इज इक्वल टू 0. अब मुझे वेरिएबल सेपरेबल की प्रॉपर्टी अप्लाई करनी है, मतलब x वाला एक साइड पे y वाला एक साइड पे करना है. सो दैट मीन्स x cos x dx इज इक्वल टू माइनस sin y dy. यहाँ पे cos y था वो मैं नीचे लेके चल जाऊंगा, डिवाइड कर दूंगा cos. ओके, नाउ वी हैव टू इंटीग्रेट बोथ साइड्स. सो इंटीग्रल ऑफ x cos x dx is equal to minus integral sin y over cos y dy. अगेन यहाँ पे प्रॉपर्टी लग सकती है f dash x over f of x dx. क्यों? क्योंकि cos y का डेरिवेटिव तो माइनस sin y, माइनस बाहर पड़ा, इसको मैं अंदर इंट्रोड्यूस कर दूंगा तो ये माइनस sin y हो जाएगा, cos का डेरिवेटिव ऊपर आ रहा है. सो द वैल्यू विल बी log ऑफ f of x और यहाँ पे लगेगी u into v फॉर्म. तो x एज इट इज integral of cos of x dx minus integral d by dx of x into integral of cos of x dx complete के integral dx is equal to, यहाँ पे फॉर्मूला लग गया log of mod cos y plus c. So that counts to be x, cos की इंटीग्रेशन आ जाएगी आपके पास sin of x minus integral derivative of x will be 1 cos x have integration sin of x dx is equal to log of cos y plus c. So it reduces to x sin x minus, now integration of sin x will be minus cos x, so minus minus plus cos of x is equal to log of cos of y plus C. So this is basically the solution of this question. One more question we are taking. So I think there will be 3 questions. They are enough for you to solve it. So question is, solve y minus of x dy by d of x is equal to a times y square plus dy by d of x. ये डिफरेंशियल इक्वेशन. अब यहाँ पे देखो हर टर्म जो है एक्स वाई में कोई टर्म नहीं पड़ी हुई. सो पहला स्टेप क्या होगा, मुझे सारी ब्रैकेट एक्सपैंड करनी है एंड देन आई विल सेपरेट द वेरिएबल्स. सो इट विल बी y माइनस ऑफ x dy by d of x इज इक्वल टू a y स्क्वायर प्लस a टाइम्स dy by dx. तो मैं dy by dx सारा कंबाइन कर रहा हूँ. y माइनस ऑफ a y स्क्वायर इज इक्वल टू x dy by dx plus a times dy by dx. So I can take dy by dx common from these two terms. So y minus of ay square is equal to x plus of a into dy by dx. अब y वाले एक साइड पे और x वाले एक साइड पे, दैट मीन्स वेरिएबल सेपरेबल फॉर्म. सो ये y वाला dy के नीचे जाएगा और ये dx जो होगा उस साइड पे जाके dx ओवर ये वाला पार्ट x प्लस ऑफ a इज इक्वल टू dy ओवर y माइनस ऑफ ay स्क्वायर. दैट विल बी इक्वेशन नंबर स्टार. फिर जब मुझे अब इसको सॉल्व करना है तो ये y माइनस ay स्क्वायर का ना तो इंटीग्रेशन निकल सकता है डायरेक्टली, ना इसका डेरिवेटिव की प्रॉपर्टी भी लग सकती है. So I need to solve this one using partial fraction. So 1 over y minus of ay square can be written as 1 upon y into 1 minus of ay. That is in equilibrium with 1 upon a upon y plus b over 1 minus ay. Taking LCM, so it will be a times 1 minus of ay plus b y. एंड इट विल बी इक्विलिब्रियम, क्योंकि जब मैं यहाँ पे एलसीएम लूंगा तो वो कैंसिल हो जाएंगे. सो नाउ आई विल सब्स्टिट्यूट y इज इक्वल टू 0. बेसिकली होता क्या है, जब मुझे a की वैल्यू निकालनी है तो उसके नीचे जो भी टर्म पड़ी है उसको 0 इक्वेट कर दो. सो y इक्वल टू 0, सो दैट मीन्स 1 इज इक्वल टू a इंटू 1 माइनस 0 प्लस b इंटू 0, सो इट विल बी 1 इज इक्वल टू a. अब सेकेंड टाइम पे मुझे जब b की वैल्यू निकालनी है, इन दैट केस आई विल सब्स्टिट्यूट 1 माइनस ऑफ ay इक्वल टू 0. दैट मीन्स y इज इक्वल टू 1 अपॉन a. तो क्या बन जाएगा, ये 1 इज इक्वल टू a इंटू 1 माइनस ऑफ a, y है 1 अपॉन a प्लस b इंटू 1 अपॉन a. सो a एंड a कैंसिल, 1 माइनस 1 0, सो 1 इंटू a इंटू 0 प्लस b अपॉन a. That means b upon a is equal to 1, or we can say b is equal to a. I'll substitute this value over here in this one. So it will be 1 upon y into 1 minus of ay is equal to a, that is 1 upon y plus b, a over 1 minus of ay. Okay. And now I'll substitute this value in equation number star. So equation star reduces to dx over x plus of a is equal to 1 upon y plus a into 1 minus of ay and dy. Integrating both sides, 1 over x plus of a into dx is equal to integral of 1 upon y dy plus a common 1 over 1 minus of ay and dy. So integration of this part will be log of x plus of a is the integration of this part will be log of y. For this part it will be a times log of 1 minus of ay divided by coefficient of y, that is minus of a, plus log c. So log of x plus of a is equal to log of y. Now this a and a cancel out, minus log of 1 minus of ay plus log of c. Now I will use the property of log, that is log m minus log n, that is log m over n. So it will be log y over 1 minus of ay plus log of c. Now log m plus log n, so it will be log m into n. Log of yc over 1 minus of ay, and that is equal to log of x plus of a. Taking anti-log on both sides, so x plus of a will be equal to yc over 1 minus of ay. This is the result, or we can cross multiply both sides, so it will be x plus of a into 1 minus of ay is equal to yc. So this is your solution, or we can further write it as y is equal to x upon a into 1 minus of ay over c. This can also be one of the solutions. I hope the concept of variable separable is clear to everyone. Now in the next session I'll be explaining the topic of the differential equation of the type dy by dx is equal to f of ax plus c. Okay, take care, goodbye.